All right, in this video, we're going to delve into the theory of everything. In our last video, we took a look at the structure of nature and came up with some new ideas for understanding the structure of nature, and that affects the physics. And so we're going to try to look for a new model, a new way to understand. Really, what we're going to, in this video, we're going to work on overturning the standard model of particle physics and just coming up with a new understanding of the model for how the forces and speed of light and all these sorts of things work together to create the physical structure and I guess mental and intellectual and all that kind of stuff, that basically the structure of existence. So the place we're going to start is in Einstein's theory of general relativity. He said that basically you have three spatial dimensions. He's talking about if you have a cosmological body, so a massive body, you're going to have the three spatial dimensions, and then gravity is going to sort of lock on around those three spatial dimensions, and the space-time is going to curve around those three spatial dimensions to create the force of gravity. And the problem is we don't see that construct in nature. Think about the planet Earth. Take the planet Earth. The planet Earth has one linear spatial dimension, which is our north and south pole, but we do not have two other linear spatial dimensions. If we did, the Earth would be an octahedron. It might still be spherical because of the space-time turning it into a sphere, but it would have two different poles running along the equator. You'd have like a front pole and a back pole, and then a right pole and a left pole. And that would be the case for all the cosmological bodies in the universe, but we just don't see that. What we see is a linear spatial dimension for all the cosmological bodies, and this is really true of atoms and stuff as well. You see a linear spatial dimension which is bisected by a two-dimensional object, a flat disk, and then those two things are sort of surrounded by what you could think of as Einstein's space-time, but by a three-dimensional object. It's really not a fourth-dimensional construct. You take, a two-dimensional object, you get a flat disk. A three-dimensional object, you get a sphere. And so what we see in nature is one dimension locking in with a second dimension, a one-dimensional construct or force or energy. We'll talk about that more, about a one-dimensional thing locking in with a two-dimensional thing, locking in with a three-dimensional thing. We don't see the octahedral nature that you would have if you had three linear spatial dimensions. So what we're basically going to do is just take these three things and start unifying them with other groups of three things running right along through this video and then on into the next video. And so the first unification here is just directly with the forces of nature, because we know the north-south pole construct is magnetic in nature. We know down in atoms, if you have a nucleus of an atom, the electron swirls around, creating a flat disk, a flat electric disk going around the atom. And we also know in cosmological space, whatever the theories of gravity are, and we're going to get to that in this video, but what we see very strongly in this solar system is the sun grabs hold of all of the planets in its equatorial disk. So it's like a force. It's like the equator, the equatorial disk of the sun, is a force that grabs on and holds on to the planets, And the planets all hold on to their moons and often the rings, like in Saturn, the most pronounced, and Jupiter and the ice giants and stuff as well. It holds on to them in their equatorial region. Even the planet Uranus, is tipped at 90 degrees, but it's still, the planet itself is locked into the equatorial force or equatorial field of the sun. And then it has some rings, some of that kind of stuff, and its moons and stuff are going around its equator. So we can pretty safely say that the equatorial region, this two-dimensional flat disk, is tied in with the electric force of nature. Then you have the concept of a sphere, and the sphere is tied with what the physicists have traditionally called the weak force of nature. Think about picture that I have two basketballs here. I have a basketball up here and a basketball down here. And imagine that they have, let's say, about 100 force lines going between them. So they're attached to each other in what we would call a gauge invariant fashion, with 100 equally balanced force lines running between these two basketballs. Now I take the bottom basketball and I squeeze it down to the size of a pea, and it moves into the inside of the other basketball. Now imagine that it continues to have a one-on-one relationship between the two spheres, the core sphere and the outer sphere, but the relationship is now become gauge variant. It's no longer gauge invariant is like my two hands. They're the same size. But gauge variant is where something is like a tiny core object and the other thing is a big thing surrounding it. And so the weak force, like it throws these W minus and W plus particles. If you picture the larger sphere, let's say there's an earthquake or something happens on the larger sphere and it goes down to the core sphere. Well, with those 100 force lines, think how condensed they're going to be down on the core sphere. So it's something from the larger sphere goes down and it hits the core. That's a W plus or W minus or a Z particle. Not in this video, but sometime I'll talk about the differences between the positive, negative, and the neutral Z particle. But also, we had for a while, physics had a big conundrum with the solar neutrino problem. And the way it solved that problem, there were not enough neutrinos or something like that. And they figured out the reason was the neutrinos were growing as they go out from the sun. They were turning from very small electron neutrinos up to the larger muon or even eventually the larger tau neutrinos. And so that also fits. The neutrinos are something that comes out from the core. They're like a time particle that comes out from the core and goes out towards the larger basketball in our model here. I don't like the word weak force for one of these great, incredible, probably the most complex force of nature. So I just call it the time force. And that's how I'll refer to it throughout these videos and stuff. So what we're saying is the first spatial dimension, a linear spatial dimension, is unified with magnetism. A two-dimensional flat disk is unified with the electric force of nature. And this three-dimensional, not four-dimensional space-time, but three-dimensional space-time is related to the force of time. And as you know, time is a variant force. If you get closer to a supermassive black hole, time slows down. This is, we talked about in the last lecture, how each smaller level is going to have a more dense field of time down in its core. And so time moves more slowly in that core. So as you keep going down through levels, you're always going to have slower time the closer you get into a deep nucleus. Okay, so that's our first unification. Now our second unification is we're going to look at the 3 quarks of the proton, and we're going to get to the neutron sometime down the road, not in these next few videos. But so we're just thinking about the 3 quarks of the proton. And what the physicists say about the 3 quarks of the proton is you have 1 down quark and 2 up quarks. And they believe the 2 up quarks are completely identical to each other. And that's also not correct. It's true, I agree completely that the physicists are completely correct. The reason they say that they are identical to each other because they have 3 things completely in common with each other. They're made up of the same amount of energy. Both of them are made up, or they weigh, you could sort of say, 2.3 MeV. They both have half spin, and they're both, the reason they call them up is they have the positive 2/3 electric charge. I agree that the 2 up quarks of the proton have those properties in common with each other, but nonetheless they are separate, completely separate particles. And this should be testable if you go to your, the super colliding superconductor or whatever, and figure out how to test the magnetic properties. One is a linear magnetic quark. It's specifically a magnetic quark. The other one is a time quark, and it's just going to have different magnetic properties when it's separated from the magnetic quark. They come together, the 3 quarks come together, but if you can, stress them or something and keep them separate and get a magnetic signature for each of those 2 quarks, it will definitely, 100%, it will be different. So this is falsifiable and testable and stuff. So the first up quark ties in with the magnetic force. Then the second up quark ties in with a time quark. And now there's another concept that we have to, the physicists don't have this wrong, but we have to make an amendment due to our new idea that we have specific time, size, speed levels in physics, that existence is made up of these levels, one level with another level and another level. And so one of the core principles of all of particle physics is that within a given time, size, speed level, 2 particles with the same charge will push away from each other. So I agree that within a given time, size, speed level, the 2 like charges are going to repel each other. But I think between a larger level and a smaller level, a larger positive charge will come and sort of surround a smaller positive charge at the next smaller level. And specifically for us right here, I think the down quark is going to be, it's called a down quark because it has a negative 1/3 charge, and it's a little tiny flat disk way down in the nucleus of the atom. And I believe that is what attracts the electron to lock on around it. And picture in our solar system for a minute, think about the sun. Now, okay, let me just as an aside say, I believe this solar system is a greater oxygen atom. And that's going to become very important as we connect that with some other time, size, speed levels and everything. This gets pretty complicated. You could say, well, there are a lot of differences between an atom and our solar system, but imagine like if the S1 orbital and the S2 orbital, which each have 2 electrons spinning in different directions, imagine that those make up our 4 inner planets. And then when we switch to the large gas giants, imagine that the electric field becomes a p orbital. So it's now, imagine it can't put out as much energy to just fill all of space like it does with the close-in planets. So instead it starts putting out that figure 8, just sort of reaching out and grabbing Jupiter, the 5th planet, with a p orbital. So it's going to have a p orbital, a whole different electric energy signature. That should also be testable eventually. And then the Saturn and the ice giants and stuff would also be parts of the p orbitals. But anyway, that's all an aside for the moment. Right now, think of the sun for the moment as having the properties of a single hydrogen atom. Okay, imagine the sun is behaving, forget the oxygen atom, which has a lot more complicated valence shells and stuff, and just think of it behaving like a single hydrogen atom, and it has, so let's say the sun itself in another dimension has a magnetic quark, which is sort of a north-south pole. It's not quite as exact as Earth. It fluctuates a bit more and stuff because it's an oxygen. But anyway, then it has the sphere, which is the surface of the sun, so that's its other up quark. Then what it has is, imagine that it has a disk, a quark level disk, and the quark level disk goes out well beyond the surface of the sun. And with the quarks, the two up quarks, they are made up of 2.3 MeV of energy. But the down quark, even though it has only a 1/3 negative charge, so they're 2/3 positive charge, but it weighs, it is made up of more than twice as much energy. Why is that? Well, think of how the sun grabs onto the entire, there's a huge solar equatorial field that goes all the way out past Uranus, out to the Oort cloud. And so I think the reason protons are set up the way they are with this very large, small, but it's very large compared to the two up quarks, that it puts out this field which goes out beyond the time and the magnetic quarks, so that the electron can come and lock in on it around it. And this is what sets up the huge solar energy field in the solar system and down in an atom. That's what, allows the electron to lock on around the small nuclear core of the proton. So that's kind of what's going on with the down quark, and that also leads now into our third unification. So for our second unification, we have the one-dimensional linear force locked in with magnetism, locked in with the first up quark, and then we have our two-dimensional flat disk locked in with electricity, the electric force, and then locked in with this down quark, which can then grab this next larger electric field. And then we have the three-dimensional object, the sphere, which is tied in with the time force, and that one is tied in with the second up quark. And there are dynamics going between. It's really not one sphere, it's two spheres. You're always, with each of these, I think you're surmising a core, a next smaller core at the center. And certainly for the spherical dynamics, there's always the whole weak force or time force has energies traveling between two spheres, but so they have these lines of force, but it comes down so that it creates this field, like an atmospheric field around the smaller sphere. So then this brings us to gravity. And once again, we have to look at something that the physicists sort of have slightly wrong, is when Isaac Newton, the apocryphal story is an apple fell on him, and he surmised that the force that makes an apple fall towards the earth is the same force that holds the moon together around the earth. And so he called this gravity and did a bunch of math which sort of works out unifying those two. But the physicists have never really challenged Newton's model there, even with Einstein's sort of upgrade in relativity and stuff. Einstein is still thinking of a unified force of gravity, and really gravity breaks up into these three kinds because Newton's model is really only talking about two things that we know gravity has to do here on Earth. One thing it has to do is explain why an apple falls towards the earth, or if you jump out of an airplane or something, you're going to fall towards the earth. The other thing it has to explain is how the moon is able to lock onto and hold on to how the earth is able to lock on and hold on to the moon, how the sun is able to lock on and hold on to the earth and all the other planets and stuff. So, but then the third thing is it has to explain what is holding the earth together. And it's just an assumption that it's this, the force that pulls you towards the earth is what's actually holding the whole earth together. What I would say is gravity breaks into a magnetic force, and that is the force that is holding the earth together internally. That's why you really have the two hemispheres that have, that spin in different directions and stuff. When you have water go down the sink in the north hemisphere, it goes one way and the other way in the southern hemisphere. Gravity, the models of gravity wouldn't explain that, but two different magnetic poles explains that. So I think we're going to get into there's a lot more to say about the magnetic force. It gets a lot more complicated, but anyway, so I'll just stop with saying magnetism is, I believe magnetic gravity is the force that holds, I'll still call it gravity. Magnetic gravity is the force that holds the planet together. And then electric gravity is what holds the moon to the earth. The earth is going to have a proton quark electric field that goes out as far as the moon, or far enough if the moon also has a quark electric field. Their two electric fields are going to find each other. So it may be, do they extend into each other, or does the Earth's field stop so the moon's out here and the Earth is over here and their fields just touch, or what? That's probably testable and measurable and stuff like that. And we know that electrons have strong magnetism involved. So I think magnetism is a physical force. I think a pure electric force is a connecting force, like the brain and a thinking force. I think you need that physical magnetism. So one of the things about the moon and the earth holding each other through the electric force, and the sun and the planet Earth holding each other through the electric force is first and foremost a communicating force. And if you go with old theories of gravity, you're essentially saying that every planet around every star around every supermassive black hole in its galaxy, you're saying that it's all just random chance, that there's somehow, this solar system is set up with incredible delicacy of where the planets are, how far apart they are, the moons that they have. Think of the rings of Saturn. All of this stuff works not just off of some one in a zillion random thing. It's all communicating through the electric force to figure out, its relationships. The moon and the earth have an electric relationship that they are holding on to each other and communicating to say how close should we be, how far should we be, how fast should we be spinning, this and that. So that's part of the nature of the electric gravity, is that communication is sort of, I think, is built into it. I may be going further than my mandate just in trying to explain electric gravity right there. But anyway, okay, with time gravity, we've sort of already gone over it. But one important thing about time gravity is, just another feature of time at any level, as like the weak force or as a gravity concept, is time is going to form a spherical object, and it's always going to be dealing with not just one other sphere at the core. It's going to be in a relationship with some smaller sphere inside of it, and then some larger sphere outside of it. And think about how time, as we understand time, always relates to the future and then to the past. You always have a present in the middle, with then a past on one side and a future on the other side. So I'm not going to go further than that right now. But if you have a core, a time core that is much, much slower speed, then an object down there could spin faster than the speed of light, faster than our speed of light. So spin, the concept of like a half spin object, the physicists have thought, well, it can't really be spinning faster than the speed of light, so it's sort of like spin, but it isn't really spin. Well, it's faster than light speed spin. But my point right here is, if Earth is like a middle sphere and it's connected with these, let's say, these 100 force lines to a larger Earth that's in a faster, but then sort of counterintuitively slower. But anyway, the forces of nature in that larger time sphere are set much, much lower energy. So from our perspective, this larger sphere has a one-on-one relationship with all of its, we'll call them time strands or something, coming down to the surface of the Earth. But so they're huge out near wherever they are in space. They might be 100 miles across, and they might come down here to the Earth and only be a foot across or something. It's much more dense, and that's what causes the gravity that if an apple falls off a tree, it drops. That's because of the one-on-one relationship being much more dense around the surface of the Earth. But so now let's say you were to go up to the outside of to the surface of this next larger sphere. To us, from our time, size, speed level, at our energy level and stuff, you get there and it would seem almost like there's no gravity at all. If you jumped out of a spaceship at that level, it might take hours for you to even slowly begin moving towards the Earth. So it seems like there's almost no time energy there at all. But because the next level, imagine that sort of like as another surface, time speed type surface, like the surface of the Earth or the surface of the sun or something. It's another surface area. It's because the next larger level has such low energies, even the energies that would seem to us humans to be incredibly, vaporous or whatever, just not even hardly real time energy at all. It concentrates where that next larger level is like a P to the next larger, huge field of time energy that is set at a much lower level. It's actually very dense and forming like a hard surface at this much faster time speed. So that's an interesting thing to think about with time. So in the next video, we're just going to continue adding on some more of these threes. We're going to go through a few things pretty quickly. And then the final one is going to be something we're going to anthropomorphize, and it's going to get really interesting and really cool as we take a look at that. So that's really the theory of everything part 2 for the next video. Thank you.